In this lesson, we're going to be talking about tree diagrams. And tree diagrams are a tool we use in probability to help us figure out how many outcomes are possible. When you first learn about probability, you learn that it's about putting the number of favorable outcomes over the number of total outcomes. So if you're talking about rolling a die that has the numbers 1, 2, 3, 4, 5, and 6 on it, and we ask for the probability of rolling an even, we would count up how many of the outcomes are even. There's 3, so there's 3 favorable outcomes out of the total outcomes, which are 1, 2, 3, 4, 5, 6. So the probability would be 3 out of 6, or 1/2. When it's a basic question, like rolling a die one time, finding the number of outcomes is pretty easy. We can just see all of them in front of us. But the problems get to be a little more complicated when we see other things are happening. So the tree diagrams are going to help us figure out how many total outcomes there are and what they are. So we're going to work through some of these examples together, and we're just going to continue making these tree diagrams to help us see what's happening. Number 1 says, a bag contains 1 red marble and 2 green marbles. You randomly pick a marble to play with, and then your friend picks a marble. So you know you have a red marble, and then you have 2 green marbles. You have green marble number 1 or green marble number 2. So the first thing that happens is you randomly pick a marble. Well, you can pick any of those 3 marbles. So when we're making a tree diagram, we start out with all of the options that are available for the first event that's happening. The first thing is you're picking a marble. You can pick a red one, you can pick green number 1, or you can pick green number 2. Now your friend picks a marble. So that's event number 2 that's happening here. This is the second thing that happens. Well, once you have drawn a red marble, that red marble is not available for your friend to draw. So the outcomes that are possible for your friend are green number 1 or green number 2. So this second one is your friend picking the marble. If you picked green number 1, then your friend can pick a red marble or green marble number 2. Or if you picked a green marble, green number 2 on the first one, then your friend can pick the red marble or green marble number 1. Now when we look at this, we see all the possible outcomes, and oftentimes we make a list of all of these possible outcomes. We have red for you, followed by green 1 for your friend, red for you, green 2 for your friend, green 1 for you, followed by red for your friend, green 1 for you, green 2 for your friend, or green 2 for you and red for your friend, or green 2 for you and green 1 for your friend. This list of outcomes right here, this is what we call the sample space. That's the total, well, it's not the total number of outcomes, but it's all of the outcomes in a list together. This part over here was the part that we call the tree diagram. And using either the list or the tree diagram, we can see that there are 6 outcomes, 6 total outcomes possible when you randomly pick a marble and then your friend picks a marble. Okay, question number 2 says a spinner can land either on red, blue, green, yellow, or purple. And then that's what that part is. Then the question says you flip a coin and then spin the spinner. So we want to think about what the outcomes are each time. When you flip the coin, the outcomes that are possible are heads or tails. When you spin the spinner, the outcomes that are possible are red, blue, green, yellow, or purple. It's important to remember that in a tree diagram, the only things that go into the diagram are these letters right here, just the possible outcomes. not the action that we're doing. So we would never say spinner and then do the options, and coin and then do the options, because spinner and coin are what's happening, so they don't go into the diagram. So for this example, the first thing that's happening is we flip the coin. So the start of it is going to represent the coin flip. And when we flip the coin, we can either get heads or tails. Then we spin the spinner, and we get one of those colors. So if I get heads, does that change what color I could get on the spinner? Well, no, the coin and the spinner are completely independent of each other. So I could get heads then red, heads then blue, heads then green, heads then yellow, or heads and then purple. Oops, that should just be a P. If I get tails, I can still get any of those colors on the spinner. So I could get tails on the coin followed by red, tails blue, tails green, tails yellow, or tails purple. So this is my tree diagram. I'm done with that part of it. And then I want to make the list of all the possible outcomes. So the list would be heads red, heads blue, heads green, and so on. And we do tails red, tails blue. This is our list, this is our sample space, because that's the list of all the outcomes. And when we count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 total outcomes. Now on these problems, sometimes they ask you to state what the sample space is. That would be the list. Sometimes they tell you to make a tree diagram. That would be the tree diagram. And sometimes they just say how many outcomes are possible, and that would be the answer 10. So we want to be careful as we're working these problems that we watch carefully for what question they're asking. Okay, number 3 says when a button is pressed, a computer program outputs a random odd number greater than 1 and less than 9. So if it's greater than 1, we have to start with 3, 5, 7. Less than 9 means 9 is not included. And then it says we press this button twice, so we're repeating the same event. And it looks to me like we can get that, we could get a 3 followed by another 3. It doesn't say anything about not being able to get the same answer twice. So when we do this, we have the first press. Well, the first time we press it, we could get a 3, a 5, or a 7. And then we have the second press. Well, the second time we can still get a 3, a 5, or a 7. And so here we have 9 different outcomes. We have 3, 3, 3, 5, 3, 7, 5, 3, 5, 5, 5, 7, 7, 3, 7, 5, and 7, 7. And that would be our sample space. And our sample space shows us that there are 9 total outcomes. Okay, let's do one more. Let's do number 16. 16 says a spinner can land on either red or blue, and you spin the spinner 5 times. So this means our tree diagram is going to have 5 separate branches. Each one of those is only going to have the letters red or blue. So the first time we spin, we could get red or we could get blue. I spread them out, you notice, because we're going to do this 5 times, so I need to be sure my diagram is big enough. Then we could, on the second spin, we could either spin a red or a blue. If we get blue first, we could spin red or blue second. So this part shows us 2 spins. Now we're on spin number 3. If we get red, red, we could still get red, right? It doesn't affect. These are called independent events because the first thing does not affect the second thing. That's 3 spins. Now we've got the 4th spin. And these do get kind of messy. So when there's a lot of trials that are happening, like 5 spins, you want to be sure to get it spread out. One of your questions may be, is there an easier way to do this process? Is there a way that's not quite so tedious? And if all we want to know is how many outcomes, then yes, we have a shortcut that we'll talk about that's a lot faster than this. But this is the way we want to use when we want to see all of the possible outcomes. This is our best method. This and listing. But to me, this helps us make a good quality list. Red, blue, each time, right? And it would look just like this if we were flipping a coin and we were talking about getting heads and tails. It would look just like this, only it would say heads and tails instead. And that's our final tree diagram. It looks a little messy because I did manage to get it a little too close together. They're kind of tough when you're doing 5, so keep that in mind next time you do one that has 5, that you want to keep it spread out, especially from the beginning. I would have moved these a little further apart. That might have helped, or even moved the B all the way down here. That probably would have helped also. So you can keep that in mind. And then we can make our list of all the possible outcomes. And we would come over here and say red, 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 red. That's the first one. And then the next one is red, 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 blue. 4 reds and then a blue. Or we could do 3 reds and then a blue and then a red. When you're doing these, you want to be really careful that you're following the lines so that you get all of the different outcomes possible. I'm going to stop listing there, but if you finish that list, you'll end up with 32 possible outcomes.